CloudDB, shaping your new normal.
Good morning, good afternoon, good evening, everyone, depending where you are around the world. Welcome to the 2021 APEC Groundbreakers Virtual Tour by Apaco UC. This year, our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 18 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. This way, you will be able to have access to all replays until December 30 through the platform. I would like to say thanks to our Oracle user groups and Java user groups, all 16 of them, that made this event possible, and also to our sponsors, Oracle Groundbreakers and your main sponsor, CloudDB. Now for today's session, Find, Fix, and Validate, Foolproof Approach for Managing Database Performance by Bjorn Bolltoft. Please feel free to ask questions at any time by using the chat window in your top lower corner, in your right lower corner of your screen. And Bjorn will be answering all your questions at the end of the session. If you have any issues during the transmission, please feel free to also let me know by using the same chat window, and I will try to help you the best I can. Also, the chat window, in the right side of the chat word, you will find a circle with flags. You can click that and select your language if you want to have the chat window information translated to another language. Without any more further ado, I want to leave you with this amazing session by Bjorn. Bjorn, the room is all yours.
Thank you. Hello, everybody. My name is Bjorn Bolltoft, and I'm product manager for in the enterprise manager area, and we're covering diagnostic pack, tuning pack, and real application testing. And this is little what this session is about. First of all, since I'm an Oracle employee, we need to have the safe harbor statement where we say that what we're showing today can change in the future, but mostly what we're actually talking about today is features that's available in Enterprise Manager since long. So we have done quite lots of research, and a couple of years ago we actually did research about the database top challenges. And one of the things that we saw from our customers was that lots of customers have lots of databases to manage by themselves. So even 40% had more than 50 databases each to manage. And another thing that we also saw from this was that when you have this amount of databases, it's quite commonly that you don't have the time to do the testing, and you see that there are problems in the production after implementing some testing changes in the database. So that causing downtime, and most of the downtime is caused by untested changes. So that's where it is important to make sure that everything that you testing is, or everything that you change in the database is tested. And this needs to be automated in the best fashion. So one thing that we also saw from our customers is that how is testing and tuning done in the past from many situations. So first of all, you have a problem in your database, and it is quite commonly that you start to read and try to figure out how should I change this? How should I make sure that these SQLs going faster and becomes better? So one, for example, you can change. You can make sure that your index are more used, and that's optimizer index cost adjusting. And the first thing that you ask yourself is which value should be the best set, and then it's also the default is 100. If I set it to 50, the index will be more used. The second thing that's coming is, did this really work, or is it just as some fiction? What we have seen, and what I used to say, is that you can get information from the users that it works or not works. Is either it becomes slower, then of course you will get information, or it becomes so much faster that you actually uh, the, the users thinks there is a problem instead. So it is not so scientific, and you can actually not prove that you have changed anything. And this is something that our DBA is putting lots of times to. So the method that we're going to talk about today is what we call find, fix, and validate. And these are the tools that you can use. So first of all, we're talking about self-diagnostic in the database. And here we have ADDM, and we have diagnostic pack that can help you to identify any type of problems in the database. Then we have the fix, and that's where we have tuning pack. So database tuning pack will provide you with lots of information about how you should tune your SQLs in the database. And of course, how should you validate this? How should you make sure that these information is, or the changes is providing you benefit in the database? And this is where database real application testing and SQL Performance Analyzer comes in the picture. So the steps is diagnostic, tuning, SQL Performance Analyzer, and find, fix, and validate. So first, just to make sure that we know what we're talking about, is that how do we measure time in the database? And database time is the most important things to talk about. And in database times, we include CPU, IO, and non-idle waits. And non-idle waits is more or less when we doing something, we waiting for CPU, we waiting for IO, and so on. And this is database time, and you should make sure that it's not same as response time, because the database time is the time spent in the database. Response time is the time the application or the user sees. So that includes also SQLnet and application server time as well. So just to see the fundamental concepts here. So in the database, we're talking quite much about active sessions. A session is active when it's doing something in the database, waiting for IO, using IO, using CPU, waiting for CPU, and so on. And the total database time is the total time spent in the database. So it is actually when you're doing something in the database. And if we look at this, this could be Amazon or some other applications. We go to the browser, we try to find a book to look at, and when we browse for the book, we may search for some keywords, and that's when we're spending some database time. And then we have quite lots of time when we try to figure out, is this the correct book? And then when we want to get more information about the book, that's when we're spending more database time. Now we're clicking on the book that we are interested in, and we get a response from the database. And after a while, we decide to select a book and we add it to the chart, and then later on we check out. So all the things that when we click enter or when we submit something in the database, that's when the database time starts in the database. And that's the database time. So first of all, let's talk a little about how we can find the time in the database. So here is the Enterprise Manager performance page. And one of the most important thing is to look at the average active sessions and try to figure out what's using and where we're using time. So here what we can see is the blue. The blue is the large time in the database. And that's where we need to focus when we try to identify some problems in the database. So we say, click on the big stuff and try to focus on that. One thing that's also important is that if we can see this is, we can see the red bar. That means that this is the amount of CPUs available in the machine. And we also see that we have peaks that's exceeding the available CPUs. That means we spend time on waiting. And we want to make sure that we reduce that time as much as possible. So when we go into, sorry for that, when we go to the database and try to identify the problem in the database, we have a few different methods. As we talked about, ADM is one of them, but we also have the Ash Analytic page in the Enterprise Manager. And here we have the ability to look at the details of your database. We can do analysis and we can drill down on in the information. We have different dimensions that we can use, and we can filter and find the most problematic areas. If we're using, for example, the load map, here we can see that GC concurrent block busy is the predominant in the database. That's cluster event in the database. So we can absolutely see where and what type of issues that we have in the database. And then we can drill down, we can look at this on more details and so on. Another part is, of course, ADM. Here we get information every hour, or we get information about what's could cause a problem in the database, where we're spending time. So ADM will tell us about findings in the database, what we have identified. And here we can see that we have SQLs that should be tuned, or at least we have SQLs that taking a long time in the database, and where we can actually try to run SQL Tuning Advisor. So it will tell us a little about the impact on these SQLs, how much they actually can impacting the performance. If we have, for example, here a certain amount of SQLs, we see 16-20% on each SQL, and that's something that we really want to make sure that we reduce as much as possible. So we have identified the SQLs, we have identified the problems in the database, and now we want to fix the problem. In Enterprise Manager or in the database, we actually have the automatic SQL Tuning Advisor. So the automatic SQL Tuning Advisor using SQL tuning sets. So we're collecting information about the SQLs. We have the ability to create SQL profiling, SQL statistic, and all that type of things. And SQL Tuning Advisor will dissect the SQL into small pieces and try to figure out where we're spending most time and where we can actually benefit from using something that's better. And SQL Tuning Advisor will come up with information like gathering statistics, creating SQL profiles, and also looking at the access structure like indexes in the database and modify the SQL as well. We don't have information about how to modify the SQL is if it's what SQL Tuning Advisor tells us, but then you need to go to the manual. But in most cases, it will actually help you to create SQL profiles and so on. And that is helping you quite much in the database. So from the ADDM findings, we can actually go directly to schedule SQL Tuning Advisor. And here we will actually take the SQLs that was problematic or used most of the time in the database, and we send them to the Tuning Advisor. And then we get information about the SQLs and how we can change and how we can get the SQLs to behave better in the database. So from this view, we can see that we have about 50 SQL profiles to adapt. We can add a few indexes in the database, and there are also statistic and alternative plans that we can use. Alternative plans is that we have executed this SQL before with the better plan, and now it's using a not as good plan, and that will in that case, you can use either plan baselines to use the most beneficial plan. So let's look at how we do this with SQL profiling. So first of all, what is a SQL profile? When we use SQL Tuning Advisor, as I said, we dissect the SQL. We actually take pieces and bits of the SQL and say that, okay, how is it more beneficial to execute this part of the database SQL first or this part of the SQL first? And that will help us to provide more information to the optimizer. So what we can say is that, okay, we can run this query with first row compared to all rows instead, and that will make the SQL much faster. And we can make sure that the joins are done correctly in the database. So the way, for example, if you have a package application, this is the most beneficial way to tune your application. You can't change the SQL. So here we need to make sure that the optimizer gets the correct information and use that information in the best manner to execute the SQLs. So there is often questions about SQL profiling or if you should use plan baseline. So one thing with plan baselines is that it's locking the query to use the plans that we have accepted. It can't use another plan. And SQL profiling is more about feeding the optimizer with new information to use the best plan. So it's little different times. You may use SQL plan baselines when you're migrating an application to make sure that the SQLs are behaving in the same way as it did before. But otherwise, profiling is something that you should use to go forward because that helps you to get a more beneficial plan. So now we're using SQL Tuning Advisor. We run SQL Tuning Advisor. We get information about the profiling, and here we get also the statistic. So one thing that in using SQL Tuning Advisor is that, of course, we get information about using statistic, but when we're running SQL Tuning Advisor, it's also running it for one SQL at a time. So what's actually beneficial for one of the SQL may, in this case, also be bad for another SQL. So good statistic for one SQL can cause regression in other SQLs. And this is something that we need to validate also. So let's do this with gathering statistic in the case. So we get information that we should implement new statistic in the database, and should we make sure that this is foolproof, then we need to validate as well. So that's where SQL Performance Analyzer comes in and helps us. SQL Performance Analyzer is part of real application testing, and SQL Performance Analyzer works with SQL tuning set. So we collecting SQL tuning sets. We have the statistic in the SQL tuning set, but we can also, if we're running this in a test environment, then we using run the queries standalone without any concurrency in the database in the test environment. And then we change what we want to change, and we get a post trial, run the trial, and we get statistic telling us about the SQLs that are regressing and improving. SQL Performance Analyzer also has the ability to act together with SQL Plan Baselines and SQL Tuning Advisor. So SQL Plan Baselines in this case, it's helping us to make sure that the query that was regressing is performing in the same way as it did before. So here is a typical SPAR report. We can see information about improvement and regressing on the SQLs and the total impact. So now we actually test executing all the SQLs in the database, and we can see that, okay, all the SQLs with the change that we implemented provided us with a 22% improvement in the database. But we also see that there are 2% of regression, and this is what we want to make sure that we can solve as well. One SQL, even if it's a small regression, then one SQL can be quite causing issues in the application if it's a very important SQL for the workflow. So we see that, okay, we have two SQLs and we can go into details. We can see what's causing the problem of the SQLs, and we can also go and run SQL Tuning Advisor or create plan baselines on the regress SQLs. When we're talking about using, we change something in the production database, then we can either set up a test system and do the change in the test system, and that's quite taking a long time. We need to set up the test system. It needs to be on separate hardware and so on. So that's quite using quite lots of resources from us as DBAs. But another problem is, can we use the production system to do the testing? Some customers may not use it. Other customers says yes, as long as it's not causing any problems. And this is where Spark Quick Check can help us. So Spark Quick Check is optimized to run in a production environment. And here we have the ability to execute SQLs and test and validate the changes that we want to implement in the production environment. It's running what we call optimized, so it's using an optimal plan and execute the SQLs only with changes. It's also controlled, so we can set time limits, we can set resource consumer groups, so it doesn't use any so much resources. And most important of all, it is test scope in a private session. So when we do a change, we do that just for the session that we are testing with. And of course, it's changed aware. So when we're changing an optimizer index or init or a parameter or something like that, then it is working in the database, and we the scope of the test is only for that part. So the way we do it is in what we call the optimize is a hybrid mode. We start to identify the SQLs with plan changes by just generate the plans, and then we extract those SQLs with plan changes. We execute those SQLs in the database. It's only SQLs that we're executing, and we execute them once in the database and make sure that it's not DML statement as well. since we have extracted the SQLs with plan changes, since they are candidate of regressing, then we reduce the amount of SQLs with at least 10 times or even more in most cases. And we just execute them once in the database. So they will not use so much resources. It's one session in the database, it's private scope, and it will not cause any conflicts with other SQLs. When we're talking about change-aware, we have the possibility. So if I'm testing, in this case, we talked about statistic, then when I see that I don't have any regression in the database with the new statistic, then from this interface, I can publish the object statistic. So in the object statistic way, what we do here is that we have the SQL tuning set, we update the statistic in pending mode. That means we update the statistic in a shadow table. We tell this session to use that statistic, and then we execute the SQLs again, or test the SQLs again, and identify the SQLs with plan changes and execute with and without the pending statistic. And what we talked about, control. So we can set SQL time limits. We can make sure that it's using a resource consumer group, and make sure that it's using resources in the best manner in the database. So that helps us to make the testing in the production database without any big impact on the database. So another use case that we can use here. So if we want to check an init.dora parameter, the way we can do it is like this. We have the optimizer index caching as an example. The default value is 0. Now we change it to 50. And what we can see on the top right side, we have validate with SPA. So now we have the SQL tuning set, we change the parameter in a private session, and then we're running everything from Enterprise Manager, and it's running automatically in the database. We go to SQL Performance Analyzer, and we see that, okay, here we have the SPA trial. It's run in the database and completed, and we can see that, okay, we have done 4 trials. So the first trial is to generate the plans before change. The second trial is to generate the plans after the change. And then we filter out the SQLs with change plans, and we execute before and after change as well. And that will help us, and we will get a report. In this case, first of all, we will see, are there any changes? Do we have plan changes? We can see that some of the SQLs have plan changes. And now we want to see the details on these SQLs. So we go in and we can see that, okay, this change was only getting negative impact on the database. So we can therefore say that, okay, we should not use this parameter, or we should not change this parameter in the database. So it's foolproofing, and we are sure that any type of changes in the database are tested and validated before we actually implement them. So that is the completion of find, fix, and validate. But let's also talk a little about, okay, other changes in the database. We want to make sure that if we upgrade the database, we can make sure that it's not causing any problems. So that's where we have database replay. And database replay is something that we worked with just because we saw that it's lots of changes in the database causing regression and causing problems in the database. And other tools like LoadRunner or even Oracle ATS did not have all the possibilities to run the test cases, run all the workflows in the database with production workload. And that's where database replay helps us. So we capture the workload from the production database. It's a recorder, and it records all user sessions and the activity. We take that recording with a copy of the database, we move that to a test system, and then we take what we call the replay drivers, and the replay drivers will run the recording against the database. And we will connect the same amount of sessions to the database and run the workload in the same way as it was in the production database. That will help us to get information about regression and problems in the database. The tier that we support is the database tier. So if you change anything in the database tier, like upgrading the database, changing platform, changing from single instance to rack or something like that, that's something that we can test. We don't test, since we capture recording everything when it enters the database, we can't test anything on the application tier. And when we have done the testing, we can get the information about how the database behaves and if there are any problems or if anything goes as expected. We can drill down on the errors that we see and identify the problems with those errors. And we can see the database time spent in the database and if everything was replayed as it was captured. We
Hi, Bjorn. Hi, Bjorn.
Hello. Yes.
Yes, sorry, you got just disconnected for 2 minutes.
Okay. I need to. Okay, so
Yeah, you need
I
to
think,
share the screen again.
yeah, I think we were more or less at the end of my session. So let's see if I can share my screen here again.
Yeah, I
Okay.
can see your screen. Thank you.
Yes. So we talked a little about database replay, and we have, I think it was this here. No, yeah. So we can also, so database replay helps us to test upgrades and so in the database. We also have the possibility to run consolidated replay. This is when we're moving to any type of consolidated environment, pluggable databases and so on. We can capture several databases and we can replay them against the consolidated database. We can also run the replay in query only mode. So that will omit the DMLs and help us to just do sanity checks of the queries in the database. A few custom references, let's take them very fast here. We have DirecTV. They used it when we for upgrades and for testing different changes in the database. One of the most biggest benefit they had was that before they had about 6.9 hours downtime, and with using real application testing and database replay, they were able to reduce the downtime and more or less eliminate it and saved quite lots of money for that. AIB, they used it for a new platform and we're testing different platforms against each other and we're able to find the most beneficial platform for them. Nationwide, that was a compression, advanced compression. So they scaled up the workload also and tested with advanced compression and made sure that advanced compression didn't have any impact on the production database. CSX, they used it for upgrading their databases. They had 400 databases to upgrade and were able to do the upgrade more or less twice as fast compared to the previous upgrade, just because they were able to identify
Hi, Bjorn. It happened one more time. It's okay.
Yeah, so I'm ready with the presentation now. Hopefully, you saw most of the reference customers that I talked about. But if there are any questions, let's take them now.
Okay. Bjorn, is possible you just share your screen with the PowerPoint with your contact information?
Yes. So let's
That is
see.
just because that way the people that English is not their first language and they want to just contact you with any question directly, they can do that. And also for the people that's watching the replays, they will be available through the platform until December 30. They can also contact you with any question when they're watching the replays.
Yes. So let's see. We do back. So here is my contact information. My name is Bjorn Bolltoft. I'm product manager for Enterprise Manager, and my contact information is bjorn.bolltoft@oracle.com.
Thank you so much, Bjorn. I'm just waiting to see if anything comes through the Facebook with any questions. In the meantime, thank you so much for all your time. I know it's very, very late for you in Germany. Thank you so much for taking the time to present to the Asia Pacific and all the global community that's watching and participating on this free event. And it's a privilege and honor to have you with us. And yep, looks like it's not questions coming. If anyone want to do that offline with Bjorn, please feel free to contact him on his contact information on the screen. And also, if you're watching the replays, you can do exactly the same. Thank you so much, Bjorn, one more time for being so late for us. And please take care and be safe. And have a wonderful weekend.
You too, and thank you for having me here and doing the presentation as well. Thank you.
Thank you so much, Bjorn. Bye-bye, everyone. Have a wonderful
Bye.
day, afternoon, or evening, wherever you are.
CloudDB, shaping your new normal.